So, in today's session, we have to start nanotechnology, in which the first topic is plant mediated synthesis of nanoparticles through green synthesis. So, before starting this topic, let me give you a brief description about nanotechnology and green synthesis. Basically, nanotechnology has received much attention recently due to its significant applications in various fields, like the physiochemical routes for the fabrication of nanoparticles. They are quite expensive and hazardous. And if we talk about green synthesis, then it employs non toxic, natural, easily, and widely available precursors. Basically, we summarized various applications of green synthesis nanoparticles, including various kinds of biomedical applications. So, let's begin with the topic plant mediated synthesis of nanoparticles. So, considering the toxicities and hazardous impact of conventional routes, your green synthesis is now becoming a promising alternative. So, our biological synthetic ways commonly lead to the facile ascent without high temperature, hazardous chemicals, and precise conditions, and utilize eco friendly and cost effective resources. So, various bioindustries are involved in the fabrication of nanoparticles like plant, algae, yeast, fungi, etc. and all. So, phytofabrication of nanoparticles featured many benefits like rapidness and all. So, basically, our research on the synthesis of nanoparticles using plant extract has been rather comprehensive in current years due to the availability of raw materials. So, let's begin with this. Plant mediated synthesis of nanoparticles, green synthesis. Then, here so, plant mediated synthesis of nanoparticles is an eco friendly, cost effective, and sustainable method that uses plant extract as reducing and stabilizing agents. So, this approach avoids your toxic chemicals and harsh conditions which are used in conventional methods. The various common nanoparticles we include are gold, silver, your zinc oxide, and iron particles. There are many more nanoparticles which can be used. So let us move further to the principle of green synthesis plant extract. They contain bioactive compounds such as phenolics, your flavonoids, alkaloids, terpenoids, proteins, and some kind of sugars. So in this bioactive compounds, your polyphenols and your flavonoids, basically these are the primary reducing agent. Phenolics and Phenolics and flavonoids are the primary reducing agent. The thing is their hydroxyl, which is the OH groups, the oxide into quinones while transferring electrons to the metal ions. वहीं पे if we talk about your terpenoids, then these are water insoluble or fat soluble compounds. They basically provide both reducing power and structural capping. And if we talk about proteins and your sugars, then basically your proteins were the functional groups of amino acids like your amine group, so they can bind to metal ions. They can act as excellent capping agent to stabilize the nanoparticle structure. So after this, basically these act as reducing agents. We have learned this thing, converting metal ion into nanoparticle, and capping agents are also the stabilizing nanoparticles. इसकी जनरल रिएक्शन है मेटल आयन एंड योर प्लांट एक्सट्रैक्ट. Your metal ion and your plant extract, when these both combines, they give you a reduced nanoparticle and stabilized nanoparticle. So, after its brief introduction, let's talk about what is the mechanism of your nanoparticles. The first step is reduction. It means metal ions they reduce to atoms, but your nucleation atoms form clusters. Now see your reduction and nucleation. Basically, the bioactive compounds in the plant extract, they donate your electrons to the metal ions to form a precursor solution, right? So this reduces the metal ion to a zero valent state. So these zero valent atom begins to cluster together, reaching a critical supersaturation point that triggers nucleation. It means it is the birth of the nanoparticles. Your reduction and nucleation, this is your activation phase. Okay. So after this we are having growth phase in which clusters grow into nanoparticles. It means as more reduced metal ions form, they diffuse towards the newly created nuclei. The smaller adjacent nanoparticles, they spontaneously fuse together thermodynamically to minimize their total surface energy for allowing the nanoparticles to grow as larger as much they can. Then after growth we are having stabilization, which is in which biomolecules cap nanoparticles. Basically this is your termination and capping phase. This phase halts the uncontrolled growth. It means aggregation of nanoparticles. So the plant biomolecules, like we are having your proteins, your amino acids, your sugars, they bind to the surface of nanoparticles, which creates a steric or electrostatic barrier that keeps the nanoparticles separated, which results in the stable and colloidal suspensions. So this is the mechanism of your plant mediated synthesis of nanoparticles. Rather than this, we are having some its advantages also, because it is eco-friendly and non-toxic. It is cost effective and simple. There is no requirement for high temperature or pressure. Rapid synthesis occurs in this. Scalable for industrial production, because it is green synthesis and it can be available anywhere. इसकी ऐसी कोई condition नहीं है कि it is not available. Its availability is everywhere. Then it is biocompatible nanoparticles. Then what type of plant we can use that it much be more effective? So in leaves we can take your neem, your tulsi, your green tea. There are their scientific names. Then in fruits you can take lemon, banana peel. Root and bark may you can take ginger root and cinnamon bark. In flowers you can go with your hibiscus and rose. Then moving to the most important step, which is the methodology or procedure of this making nanoparticles. To begin with this, the first step we are having is preparation of plant extract. In this, you have to collect your fresh plant material, then wash thoroughly it, cut it into small pieces, then boil that plant extract into 60 to 80 degrees Celsius for 10 to 20 minutes. Then after your distilling, your boiling it, you have to filter the extract and collect the filtrate. Then in second step, you have to make the metal salt solution. Of aqueous 1 mm AgNO3 you can make of, or you can go with other metal ion. So in this, after this you have to make the synthesis of this. Basically you have to mix both the solutions, your plant extract with metal ion solution. In first beaker you have to make your plant extract solution, and in another one you have to make your metal salt solution. And in the synthesis part you have to mix these both solutions into one beaker. Then stir it continuously to observe the color change. Then incubate at room temperature, or you can do a mild heating. After this, the step 4 we are having is purification. You have to go with centrifuge mixture, or then after that you have to you will get some pellets. You have to wash them, and after washing them you have to dry those nanoparticles. Moving to another topic, which is the factors affecting synthesis. Your pH can affect your temperature, metal ion concentration, extract concentration, and reaction time. So now let's talk about how they affect your synthesis. Basically, if we talk about pH, then altering the pH changes, they can be the oxidation or reduction potential of the biomolecules, basically dictating whether a reaction is spontaneous or not. So high pH level can often lead to smaller or more uniform nanoparticles, right? If we talk about temperature, then increasing the reaction temperature generally speeds up the reduction and nucleation rates, so resulting in smaller particles up to an optimal limit. Then extract concentration, basically the ratio of plant extract to the metal salt precursor, it governs the availability of reducing molecules, which directly affect the size and geometry of the final nanostructures. Then after this we were having its applications. It can be used as your biomedical, in this it can be your antibacterial, drug delivery, or cancer therapy, your environmental, water purification, pollutant degradation. In industries it can use for catalysis and sensors, and there are many more applications further. So after the whole experiment, we were having some limitations out of it, like variation in plant extract composition. It can be very difficulty in large scale uniform production of nanoparticles, and limited control over nanoparticle size and shape. So here we have completed our this topic, plant mediated synthesis of nanoparticles through green synthesis.